The next math concept I want to talk about with you is hanger diagrams. Hanger diagrams look pretty confusing, but what I need you to think of them as is a pan balance. We're determining whether or not both sides of the equation are equal. So if I took this pan balance and I put a cup on one side, it's pretty obvious that is not equal. So I would have to put a cup on the other side, and then the pan balance would be equal. So 1 cup equals 1 cup. Now, if I'm trying to determine the equalness of things that are not the same, like 2 nickels, I'm going to put 2 nickels on the pan balance, and clearly 2 nickels are not equal to nothing. So I'm going to start putting cups until it balances out. So far I have 3, I have 4, I have 5, and I need to go back and make sure that my nickels are set up in the pan balance correctly so they're in the middle and it's sort of a fair trial. And I end up with 2 nickels equal 5 cups. So that pan balance obviously is balanced. Those two things are equal. Let's look at a hanger diagram that represents the exact same information. I have 2 x's, and then I have 5 squares. It's balanced. And what that means is, if you were to write an equation, 2x equals 5. We don't know what the x's are right now, but that would be the equation. 2 x's equal 5. So I could then figure out what 1x was, because if I have 2 of them, I need to then divide this in half. So then each x equals 2.5 or 2.5. Pretty simple. Let's take a look at one that's a little bit more complicated. This hanger diagram has 6 ones, 1, 2, 3, 4, 5, 6, on one side, and it is balanced with a W and a 1. So if you were trying to write that out as an equation, you would put 1, 2, 3, 4, 5, 6, 6 equals W plus 1. And then if you wanted to solve this equation, you could say, okay, well, let's take away the 1 over here. Let's subtract 1 over here, which means W equals 5. Looks really tricky, but they're just trying to give you a math diagram that demonstrates the exact same information about equalness that a pan balance does.